Hey there guys, welcome to my walkthrough of the June 2017 Edexcel Foundation GCSE Maths Paper 1. Be sure to check out my description where there's so much useful stuff, including a playlist containing every Edexcel Foundation past paper walkthrough. Okay, let's go. Okay, question 1 wants us to work out the value of 2 to the power of 4. So, 2 to the power of 4 means 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Question 2 wants us to write 7.26451 correct to 3 decimal places. Okay, so the third decimal is the 4, but it's not as simple as 7.264, you have to look at the next digit, which here is a 5. That tells us to round the 4 up 1, so we get 7.265. 3a wants us to simplify 7 times e times f times 8. Okay, so multiplication is magic. It doesn't matter which order we carry out the multiplications. So we can rewrite this as 7 times 8 times e times f. Now, 7 times 8 is 56, and e times f we can just write as ef. So we got 56 times ef, which we can finally write as 56 ef. Part B then wants us to solve x over 5 is equal to 2.5. So, first of all, it's probably easy to think of 2.5 as 2.5. So we've got x over 5 is equal to 2.5. Now, x over 5 means x divided by 5, so to cancel that out, we multiply both sides by 5. So, x is going to be, 5 times 2 is 10, 5 times 0.5 is 2.5. 10 add 2.5 is 12.5. Cool. Question 4 wants us to write 4/5 as a percentage. So you might know this straight away, it's 80%. If you don't, let's show you how we could work it out. So, percent means per 100. In a fraction, you can think of the line as being the word per. So 4/5 means 4 per 5. Now if we can turn the bottom into 100, we're then going to have a percent. So to turn 5 into 100, we multiply it by 20. Now, whatever we do to the bottom, we must also do to the top. So 4 times 20 is 80. 5 times 20 is 100. 80 over 100, 80%. Cool. Number 5 wants us to work out 60% of 70. Okay, so work out 10% first of all. So 10%. To find 10% of any number, you divide it by 10. So 10% is 7. Now 60% is 6 times 10%, which is 6 times 7, which is 42. Okay, number 6. Sammy spins a third spinner. So we can see there are 4 sections, 1A, 2B and 1C. Part A. On the probability scale, mark with a cross the probability that the spinner will land on B. Okay, so 2 of the sections are B, there are 4 sections. The probability then of landing on B is 1/2. Not quite sure what that is. Cool. Okay, then part B, on the probability scale, mark with a cross the probability of getting an F. So there are no F's on the spinner, that means it's impossible, that means the probability is 0. Cool. Okay, number 7, first big question. So Fahima buys 2 packets of bread rolls costing £1.50 for each packet, 1 bottle of ketchup costing £1.60, 3 packets of sausages. Fahima pays with a £10 note and gets 30p change. She works out that 1 packet of sausages costs £2.30. Is she correct? We must show how we get our answer. So, we know that if she pays with a £10 note and gets 30p change, the total cost is £9.70p. So if we work out the cost of the bread rolls, add the cost of the ketchup, take that away from £9.70, that will leave us with the cost of 3 packs of sausages, and then we can work out the cost of 1 pack. So the cost of 2 packets of bread rolls is going to be 2 times £1.50. So the cost of rolls is £3. And we know the cost of the ketchup is £1.60. So, altogether, that's £4.60p. Now the cost of the sausages then is £9.70 minus £4.60. Okay, starting from the right, 0 takes 0 is 0, 7 takes 6 is 1, 9 takes 4 is 5. So, 3 packs of sausages cost £5.10p. Now, 1 pack is £5.10 divided by 3. So, let's use the bus stop. So, 3's into 5 go once. Remainder 2. 3's into 21 go 7 times. And then 3 into 0 goes 0. So, the answer, is she correct, is no. 1 pack costs £1.70p. Okay, 8a wants to work out 5/8 times 3/4. So multiplying fractions is the nice one. You multiply across the top and across the bottom. So we're going to get 5 times 3 over 8 times 4. 5 times 3 is 15. 8 times 4 is 32. Boom. 8b wants us to work out 2/3 minus 1/4. Okay, so to add or subtract fractions, they need to have the same number on the bottom. So, what's the first number that 3 and 4 both go in 2? It's 12. So, to turn 3 into 12, we're going to multiply by 4. Now we have to do that to the top as well. And to turn 4 into 12, we're going to multiply by 3. So we're then going to get 8/12 minus 3/12. Now when you have the same number on the bottom, you just add or subtract across the top. So here we're going to get 5/12. Cool. Okay, question 9. 4 marks. Sean works for a company. His normal rate of pay is £12 per hour. When Sean works more than 8 hours a day, he is paid overtime for each hour he works more than 8 hours. So if he works for 9 hours, he gets paid 8 times £12 and then 1 hour at the overtime rate. Sean's rate of overtime pay per hour is 1 1/4 times the normal rate of pay per hour. On Monday, Sean worked 10 hours. Work out the total amount of money Sean earned on Monday. Okay, so let's work out his normal pay. So 8 times £12. Now 8 times 10 is 80, 8 times 2 is 16, 80 add 16 is 96. Okay, now let's work out his overtime rate of pay. So his overtime rate is 1¼ times £12. Now that means he gets 1 times £12, which is £12, and a quarter of £12, which is 12 divided by 4, which is 3. So add those together, his overtime rate is £15. So his overtime pay is 2 times £15, which is £30. So his total pay is 96. Add 30, starting from the right, 0 add, sorry, not that, 6 add 0 is 6, 9 add 3 is 12, so because there's no hundredths column we can just put 12, like that, £126 is the answer. Okay, number 10. A farmer has 20 boxes of eggs. There are 6 eggs in each box. We want to write as a ratio the number of eggs in 2 boxes to the total number of eggs, giving our answer in its simplest form. So, total number of eggs is 6 times 20, which is 120 eggs in 2 boxes. 2 times 6 is 12. So, as a ratio, let's call it 2 boxes to total, we get 12 to 120. Now there's a common factor there of 12. Divide that away, we get 1 to 10. Cool. Okay, number 11, we got sequences and terms and things, so my playlist is down below. So a sequence of patterns is made using circular tiles and square tiles. We're given the first 3 patterns. Part A asks us how many square tiles will be needed to make pattern number 6. So, let's write down the numbers of square tiles needed and see if we spot a pattern. So, pattern 1, we need 1 square. Pattern 2, we need 4 squares. Pattern 3, we need 9 squares. Now, hopefully these numbers look familiar. they are square numbers. So 1 squared is 1, 2 squared, 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. So to get the number of square tiles we need, it's the pattern number squared. So for the 6th, 6 squared is 6 times 6, 36. Part B, a little bit trickier. How many circular tiles are needed to make pattern number 20? Okay, so obviously we don't want to draw 20 of these patterns, so what we're going to do, we're going to get the first few terms and then work out the nth term. So for pattern number 1, we need 4 circles. For pattern number 2, we need 8 circles. Okay, so there is a pattern going on, we're not really going to need to worry about nth terms. For the third one, we need 12 circles. So, hopefully you can see what's going on here. This is our 4 times table. So the number of circles needed is 4 times the pattern number. So for the 20th, we're going to need 4 times 20, which is 80. Cool. Okay, then for part C, Derek says, when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek correct? You must give a reason for your answer. So remember the square tiles come from our square numbers. Square numbers are when you multiply a number by itself. So Derek is right. The reason being, because the odd pattern is going to need that odd number times itself, number of square tiles, it's going to be odd. So our reason could be that the number needed is the pattern number squared odd times odd is always odd. So that would do it. Cool. Okay, number 12. There are only 7 blue pens, 4 green pens, and 6 red pens in a box. 1 pen is taken out at random. Write down the probability that the pen is blue. Okay, so the way the probability works is, where we can, we always want to use fractions. The top number is the number of things we are interested in, so here the number of blue pens, and the bottom is the total number of things that here, for example, are in the box. So the number of blue pens is 7, and the total number of pens is 7 add 4 add 6, which is 17. So it's 7/17. Okay, number 13, bit of a strange one. So the diagram shows a man and a tree. we are told the man is of average height, and the man and the tree are drawn to the same scale. Part A wants us to write down an estimate for the real height in meters of the man. So, what's average height? About 1.8 meters, maybe. I'm about that. I'm quite average. So, that's what we'll go for. Part B wants us to write down or find an estimate for the real height in meters of the tree. So because they're drawn to the same scale, we're going to use our estimate of the man to estimate the tree. So I would say the tree is about 5 times the height of the man. So let's say the tree. Now we can put a squiggly equals sign, that means is approximately 5 times 1.8 meters. Now 5 times 1 is 5, 5 times 0.8, well, think about 5 times 8, that's 40, 0.8 is 10 times smaller, so that's going to give us 4, so 5 times 1.8 is 9 meters. Cool. Okay, number 14, we got a pie chart. So, Year 9 students at Halley School were asked to choose a language to study. The table shows information about their choices. So we've got French, Spanish, and German. Part A wants us to draw an accurate pie chart for this information. So you probably noticed we've got an empty column in the table. That's to work out the degrees that each language is going to have in the pie chart. So the first thing we need to know is how many students there are. So we need to add together 56, 40 and 24. So because the 4 and 6 connect together to make a 10, I would add 24 and 56 first. So that will give us 80. And then add 40, we get 120. Now, in a pie chart, the degrees of each sector have to add up to 360. So, we have 120 students that need to make up 360 degrees. So the next thing to work out is how many degrees each student is worth. So for that, we do 360 divided by 120, which is 3. So each student is worth 3 degrees. So to work out the degrees of each segment, we multiply the number of students by 3. So 3 times 56, well 3 times 50 is 150, 3 times 6 is 18, so we get 168. 3 times 40 is 120. And 3 times 24 is 72. So you now need to use your protractor to draw the pie chart. It's already done. Not quite sure though why I've got an E. Should be an F. So mine is an estimate. You make sure you use your protractor to do this exactly. You should get something that looks like this. Don't forget to label each segment. Okay, then for part B, Year 9 students at Lowry School were also asked to choose a subject to a language to study. The accurate pie chart shows their results. Good times. Shamina says, the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Halley School. Is she right? We must explain your answer. So you can see why she's saying it. Compare the size of French there with the size of French there. The problem is we don't know how many Year 9 students there are at Lowry School. So the answer is no. She isn't correct. What it does show is that a greater proportion chose French at Lowry, but because we don't know the number of students, we can't say whether it's more or less. So we can just say, no, we don't know. The number of Year 9 students at Lowry School. Okay, number 15, we got a triangle and a rectangle. We are told the area of the rectangle is 6 times the area of the triangle. Our mission is to work out the width of the rectangle. Okay, so if you haven't already, check out my formula video down in the description with all the formulas you need to know. So if the area of the rectangle is 6 times the area of the triangle, first thing we're going to need to work out is the area of the triangle. So the area of the triangle is base times height divided by 2. So 8 times 9 is 72. Divide that by 2, we get 36. Could also do it slightly differently, half the 8 and then just do 4 times 9, which is also 36. Okay, so we know then that the area of the rectangle is 6 times that. So area of the rectangle is 6 times 36. Now 6 times 30 is 180. 6 times 6 is 36. 180 and 36 is 216 centimeters squared. Okay, So, now that we know the area of the rectangle, we want to work out the width. So, we know area of a rectangle is base times height, or here, 16 times the width. Now we know that that is equal to 216. So, to get the width on its own, divide by 16, so the width is 216 divided by 16. Now we could use the bus stop on that, but I think that might be a little bit scary, maybe. So what we're going to do instead is simplify the fraction as much as we can. So between the top and the bottom, there's a common factor of 2. So 216 divided by 2 is 108. 16 divided by 2 is 8. There's another common factor of 2, so we can get 54 over 4. There's another common factor of 2, we can get 27 over 2. So, we want to divide 27 by 2. Half of 27 is 13.5 centimetres cubed. Okay, 16, bit of physics. So, V is U add A T. U is 1, A is minus 3, and T is 1/2. We want to work out the value of V. So, just substitute the numbers in, we get V is equal to 1 minus 3 times 1/2. So this is 1 minus 3/2. 3/2, if you prefer, is 1.5. 1 minus 1.5 is minus 0.5. Okay, question 17. So really, this is simultaneous equations, so I'll put my playlist down below. So 5 tins of soup have a total weight of 1,750 grams. 4 tins and 3 packets of soup have a total weight of 1,490 grams. We want to work out the total weight of 3 tins and 2 packets of soup. Okay, so it's 4 marks. So what we can do from the first line, 5 tins weighs 1,750 grams, we can work out the weight of 1 tin. So if we call it tin T, and the packet, you guessed it, P. And from the first line, we can say that 5T is equal to 1,750 grams. So to work out the weight of 1 tin, we divide by 5. So T is 1,750 divided by 5. So 5 into 1 doesn't go. Carry the 1. 5s into 17 go 3 times. Remainder 2. 5s into 25 go 5 times. 5s into 0 go 0 times. So 110 is 350 grams. From the second line, we'll end up 4 tins and 3 packets weigh 1,490. So from that, we can say 40 add 3p is equal to 1,490 grams. Now we know the weight of 1 tin is 350. So that means 2 tins is going to be 700. So that means 4 tins is going to be 1,400 grams. So 1,400 grams, add 3 packets is equal to 1,490 grams. Take away the 1,400 and we get 3p is equal to 90 grams. So 1 packet is equal to 30 grams. So now we know the weight of a tin and the weight of a packet. We can now work out 3 tins and 2 packets. So 3t add 2p is equal to 3 times 350 grams add 2 times 30 grams. So 3 times 350, 3 times 300 is 900, 3 times 50 is 1,050 grams. Two times 30 is 60 grams. So altogether that's 1,110 grams. Cool. Okay, number 18. Balina, maybe, has a garden in the shape of a circle of radius 10 meters. He is going to cover the garden with grass seed to make a lawn. Grass seed is sold in boxes. Each box of grass seed will cover 46 meters squared of garden. Balina wants to cover all of the garden with grass seed. Part A wants us to work out an estimate of the number of boxes of grass seed Balina needs. You must show your working. Okay, so each box covers 46 meters squared. What we need to do is work out the area of the garden. So, again, if you haven't checked out my formula video, do so. Here, we need the formula for the area of a circle, which is pi times the radius squared. So, the area of the garden is pi times 10 squared, which is 100 pi meters squared. Now, we're estimating pi is 3.1415, 9265358, blah blah blah. Goes on forever. As we're estimating though, we're just going to say that pi is approximately 3. So the area of the garden is approximately equal to 300 meters squared. Now, that's the area then we need to cover with grass seed. It's not a very nice number that the area one box covers is. So we're going to round also 46 meters squared up to 50 meters squared. So we're going to say one box covers roughly 50 meters squared. So the number of boxes needed is approximately the area of the garden divided by the area one box covers. So we are going for 6 boxes. Okay, then part B asks us, is our estimate for part A an underestimate or overestimate? Okay, so let's think about what we've done. We rounded pi down, so our estimate of the area of the garden is smaller than the actual area, and we rounded the area one box covers up by 4 meters squared. So we've actually worked out an underestimate. Now the reason being is that we used a smaller area for the garden and a greater area per box. Cool. Number 19, a wants to solve for lots of x minus 5 is equal to 18. So there's a couple of ways we could do this. The way I'm going to go for is expanding the brackets and solving from there. So, if we expand, 4 times x is 4x. 4 times minus 5 is minus 20. That is equal to 18. Now, we want to get x on its own, so let's get rid of the minus 20. So to get rid of a minus 20, we add 20 to both sides. So we get 4x is equal to 38. Now, 4 doesn't go into 38, so what we could do first of all is divide both sides by 2. So we get 2x is equal to 19. And then divide by 2 again. We can say that x is 19 over 2. That's fine. Or if you want to write it as a decimal, we can use the plus stop. So 2 into 1 doesn't go. Carry the 1. 2 into 19 goes 9 times, which is 18. So there's 1 remainder. So what we do, we put a point 0 on the bottom and a point up above. Carry the 1 to the 0, and then 2's into 10 go 5 times. So 9.5. Cool. Part B, inequalities. So I'll put my solving equations and inequalities playlists down below. We are told t is greater than minus 3 and less than or equal to positive 2, where t is an integer, so that means whole number. We want to write down all the possible values of t. Okay, so t is strictly greater than minus 3. So it's not allowed to equal minus 3. So the first number it's allowed to be is minus 2. Then minus 1. Then 0. Then 1. And it is allowed to equal positive 2. Okay, number 20. Asmol, would you believe it? Great name. Asmol is paid £1,500 per month. He is going to be given a 3% increase in the amount of money he's paid per month. We want to work out how much money Asmol is paid per month after the increase. Okay, so we need to find 3% of 1,500 and add it on to £1,500. So 1% of 1,500. Well, to find 1%, you divide by 100, so that's 15 quid. So 3% is 3 times that, which is £45. So Asmol is going to be paid £1,545. Okay, number 21. So this is the first question, also on the higher paper. So the scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. So we got the maximum temperature up the side and number of hours of sunshine along the bottom. Part A says one of the points is an outlier. Write down the coordinates of this point. Okay, so an outlier is a point that doesn't fit with the rest of the data. So it's this chap up here. So his x-coordinate, if we go straight down, is 10, because it's there, and his y-coordinate is 19, so it's 10, 19, Part B, for all the other points, write down the type of correlation. Okay, so we can see that there's a general trend that as we move to the right, the points go up. So that means as the number of hours of sunshine increase, so too does the maximum temperature. So this is positive correlation. Okay, then for part C, we're told in another British town on the same day, the maximum temperature was 16.4 degrees Celsius. Estimate the number of hours of sunshine. Okay, so for that, we're going to use our graph, and what we're going to do is draw a line of best fit, and then we're going to use the line of best fit. So the line is going to look something like that. That looks quite good. So, what we then do is find 16.4 degrees Celsius. So be careful with the scale. Every 10 little squares represents 2 degrees. So every little square is 0.2. So 16.4 is there. So we go across from that till we hit the line. It is about there. And then we go down to the x-axis, which takes us to about that. So again, be careful with the scale. That's about 12.6. So you might get a slightly different answer because you will have a different line of best fit. As long as it fits with your line and your line fits well with the points, you're cool. Okay, then part D. A weatherman says temperatures are higher on days where there is more sunshine. Does the scatter graph support his claim? Give a reason for your answer. So, we've already said that there is positive correlation between the number of hours of sunshine and the maximum temperature. So the scatter graph does support his claim. So we would want to say on the graph in general, so ignoring the outlier, it was hotter in towns with more sunshine. Cool. Number 22 wants us to write 56 as the product of prime factors. So this means, this is when we get fact trees out. So, we put 56 at the top and bring 2 branches off. So, try and think of a prime number that goes into 56. It's even, so 2. Now 2 is prime, so we circle it. Now, for the other branch, we need to do 56 divided by 2. So, 2's into 5 go twice. Remainder 1, 2's into 16 go 8 times. So, it's 28. 28 is not prime, so now we do the same with 28. So 28 again is even, so we can bring out a factor of 2, and that goes in 14 times. 14 then is 2 times 7. 7 is prime. So now what we do is we say 56 is equal to 2 times 2 times 2 times 7. Now for this question, that would be fine if they asked for it in index form. We would need to sharpen it up and write that as 2 cubed times 7. Cool. Okay, question 23 wants us to work out 54.6 times 4.3. So, multiplying decimals can be quite scary. The method that I would highly recommend using is called the Lattice Method. Lattice Method doesn't care a single bit about decimals. So, set it up just like the grid method. So we're going to need a 3x2 grid. Now where it starts to be a bit different is that we now need diagonal lines going up from bottom left to top right of each box. Now if you've never seen this and you're thinking this looks scary, believe me, it's really nice. Just practicing a bit. So 54.6 we're going to put across the top, but instead of thinking it has 54 and 0.6, we just put 4.6. And then down the side, down the right hand side, very important, we put 4.3. So now each box is a multiplication between the thing on the side and the thing on the top. So 4 times 6 is 24. Change colour. So 24. 4 times 4 is 16. 4 times 5 is 20. 3 times 6 is 18. 3 times 4 is 12. 3 times 5 is 15. So, to finish this off, we now start from the bottom right and add up along these diagonal lines. So the bottom right is nice, it's just 8. Then we got 4 add 1 add 2, which is 7. Then we got 2 add 6 is 8, add 1 is 9, add 5 is 14. So when you get a double digit number, when you're adding up, it's just like column addition. We're going to put the unit here and carry the 1 to the next diagonal. So now we got 1 add 1 add 0 add 1, which is 3, and then we just got the 2 up there. Okay, so now what we need to worry about is where the decimal goes. So imagine this decimal is cruising on down here, this decimal is cruising on over to the left. Now where they meet, they roll out on that diagonal line. So our decimal is going to be there. So our answer is 234.78. Boom. Okay, number 24. So we got this square ABCD. We're told the area of this square is equal to 10 centimeters squared. We want to show that x squared and 6x is equal to 1. Okay, so the square is also broken into 2 smaller squares and 2 rectangles. So what we're going to do is work through each part and work out its area. So this top left square are sides of length 3, so the area of this bit is 9 centimetres squared. Now we got this bottom right square that has sides of length x. So the area of this part is x squared centimetres squared. Now each of these rectangles are the same. So one of the sides is 3 and the other is x. So the area of the rectangles is 3x centimetres squared. Now we know that all 4 of those bits add up to 10 centimetres squared. So we know then that 9 add 3x add 3x add x squared is equal to 10. Now if we sharpen that up a bit, we can say that x squared add 6x add 9 is equal to 10. So the last thing to do, subtract the 9, x squared, add 6x is equal to 1. Boom. 25. This rectangular frame is made of 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Our mission is to work out the total weight of the metal in the frame. So to be able to work out the total weight, we're going to need to know the total length of metal in the frame. So we already know 4 of the 5 parts. Because this is a rectangle, this side is also 5 meters, and the top is also 12 meters. What we need to do is work out the length of the diagonal. So let's pull half of this frame up. So we've then got a right-angled triangle. Now what do we know we can use in right-angled triangles if we know 2 sides to work out the third side? Starts with P and rhymes with Pythagoras. Well done, Pythagoras. So again, if you haven't checked out my formulas video yet, do, it's down below. So Pythagoras tells us if this side is A and this side is B and the longest side is C, A squared add B squared is equal to C squared. So if we shove our numbers in, 5 squared add 12 squared is equal to C squared. Now 5 squared is 25, 12 squared is 144. What am I doing? So 25 add 144 is equal to C squared. 25 add 144 is 169. Now, Edexcel are really horrible. That is a square number, probably not one that you're too familiar with. The square root of 169 is 13. So, C is 13 meters. Okay, now we can work out the total length. So it's 2 times 12, that's 24. Add 2 times 5, which is 10. Add 13. So that's 24 add 10 is 34, add 13 is 47 meters. So, remember that we know the metal weighs 1.5 kilograms per meter. So the total weight is 47 times 1.5 kilograms. So 47 times 1 kilogram is 47 kilograms, and then 47 times 0.5 kilograms, that's half of 47, so that's 23.5. So the total weight is 47 add 23.5. That is going to give us 0 add 5 is 5, 7 add 5 is 12, 7 add 3 is 10, put the 0 there, go with the 1, 4 add 2 add 1 is 70.5 kilograms. Cool. Okay, 26, we've got equations of straight lines, so I'll put my playlist down below. So the equation of line L1 is y is equal to 3x minus 2, and the equation of line L2 is 3y minus 9x add 5 is equal to 0. We want to show that these two lines are parallel. So, if two lines are parallel, it means they have the same gradient. So, the general equation of a straight line is y is equal to mx add c, where m is the gradient and c is the y-intercept. To be able to read the gradient of a straight line, the equation needs to be in this form. So straight away, we can say the gradient of L1 is 3. Now for L2, we need to rearrange 3y minus 9x add 5 equals 0 to get y on its own. So 3y minus 9x add 5 is equal to 0. So we're going to add 9x, so 3y add 5 is equal to 9x. Subtract 5, so 3y is equal to 9x minus 5, and then divide both sides by 3. So we get y is 9x divided by 3 is 3x, and then minus 5 over 3. So the gradient of L2 is also 3. So L1 and L2 have equal gradients, so are parallel. Cool. Okay, final question 27, we've got vectors. So ABCD is a parallelogram. The diagonals of the parallelogram intersect at O. So diagonals of a parallelogram meet at the centre of the shape. So O is the midpoint of both diagonals. So we're told that vector O to A is little a and vector O to B is little b. Part A wants us to find in terms of little b the vector D to B. So that means, how do we get from here to here? So, as I just said, the points where the diagonals meet are the midpoint of each diagonal. So it's halfway along. So if O to B is little b, D to B is 2 times that, so it's 2b. Okay. Part B says, find in terms of A and B the vector A to B. So we want to get from A to B. Now we can only use vectors that we know, so we're going to have to go backwards along A and then forwards along B. Now when you go backwards along a vector, you are doing negative that vector. So it's going to be minus A add B. Okay, then part C. Find in terms of A and B the vector A to D. Okay. So this time we want to get from A to D. Now remember, we know the vector D to O is little b. So we're going to have to go again backwards along A to get to O, and then we're going to go from O to D. So this is minus A minus B. Okay guys, that's the end of the paper. Don't forget you can get to every past paper walkthrough down below, all in one playlist. If you found this useful, give us a thumbs up, get subscribed, share with your friends, they may need help too. Take care, take it easy.